So, the Human Brain Project, HBP. This Human Brain Project is very different than the Blue Brain Project because the Blue Brain Project sits only here, in the top left corner, the simulation aspect of it. But the Human Brain Project has many other new, different aspects because the whole notion here is to develop a platform for understanding the brain, but also using this platform not only to understand the brain, but also to develop new technologies, to develop new supercomputing capabilities, to develop new visualization of activity, anatomy of large networks, to develop new microchips, neuromorphic, brain-inspired microchips that are very cheap energetically and very efficient as a basis for modern computers or maybe even for modern robots. So there are all these many aspects that, of course, I don't have now time to talk about each one separately, but I want to mention one thing that to me is very important. The aspect of society, the aspect of education. Because we are now approaching a new era with this big project. This new era will provide new amazing information, new amazing technologies, very useful for society, that will impact society in many ways. It will have ethical, it will have industrial, it will have sociological implications, and we, as scientists, are responsible for telling you, the public, what comes out of this project. So within the Human Brain Project, beyond the technology and the neuroscience and so forth, there is the society aspect. How do we interact with you? Ongoing. And so we develop a platform, an idea how to interact, how to interface between us and you through museums, science museums, ongoing, online, there will be a brain corner, and so on. I'm not going to talk about this issue and also the ethical aspect that may emerge from such a project. I'm just saying that we are very aware of this society aspect. I want also to emphasize that this is a global project. You can see all the countries in Europe and also in America and also in South America that are involved. It's led by Europe. It is led by the EPFL, by the École Polytechnique in Lausanne. It is led by Henry Markram and his colleagues, us, but eventually many countries like in England and in Sweden and in Norway and in Israel and in Italy and in Spain are involved. You can see how many labs are part of it. You can see how many institutions. So this whole project, this €1 billion project, will be distributed trying to combine efforts, to integrate efforts, expertise from Spain about anatomy, expertise from physiology in one place, expertise in computers in another place, expertise in modeling in a third place, in order to really achieve the goal. And the goal is built from basically, in a nutshell, from three, one may say, pillars. The neuroscience is clear. We're trying to understand the brain. So there is the building a platform for databasing the brain. I already mentioned it. Okay. There is the medical aspect. So we are trying to improve our understanding of diseases of the brain. So there is the medical aspect of it. And there is the future computing, the emerging technologies coming out of this project. So this project basically is a platform project. It's not about now finding details, it's about developing approaches, both in neuroscience and in medicine and in future computing. And these approaches should be inspired. This platform is inspired by what we understand about the brain as a computing device. So we want to get new understanding of the brain, of course. We want to get new treatments from brain diseases. And we want to get new brain-like computing technologies. Because the claim here in this information and computation technology-based research here this project is part of this future emerging technologies of Europe. The claim is that the brain is a physical system that computes extremely efficiently, very efficiently. I'm just drinking water for this lecture, and here I can stand and do millions of computations very, very cheaply in terms of energy. So the supercomputers now take so much energy that we cannot easily increase it by 1,000,000. But we do all these computations successfully most of the time with very cheap 20 watts. Can we learn from the brain to develop the future technologies of computer? So this is the future computing aspect. And of course, within each one of them, we are going to build technologies. Neuroinformatics, databasing, approaching, querying the data in a very sophisticated way, simulation techniques, new mathematical approaches, new algorithms for simulations of the brain, medical informatics, databasing the diseases, and so on. We also, as I said, want to be inspired by the brain and develop neuromorphic computing based on spikes, based on synapses, artificial synapses in hardware, and eventually neurorobotics. Robotics, like we are physical robots behaving in the world, can we build robots based on what we learned about us, about our body, about our brain? So within the brain simulation, of course, we have simulations at many levels. We need to simulate genes, synapses, networks, and the whole brain. And maybe each level requires some particular approach mathematically, some particular equations that are better to describe this level, and so forth. All this simulation should be unified in some way that we can easily move from this level to this level mathematically. And this really requires deep thinking and very good mathematical theoreticians. So we want to really eventually use all this kind of integrated approach to take fragments of data, be inspired with this data, put them together in the model, and the model will give us predictions. We don't think we need to know everything in advance to build the brain. We need to get principles from building from what we already have, pieces of the brain, fragments of the brain. From fragments, we shall get the understanding of the whole, because pieces will fall within each other and the puzzle will come out. We don't need to put all the details one after the other because of the constraints by already what is already known and put inside. So this is the idea about simulations on which I talked a lot. About in medical informatics, one of the problems you may know is that the physicians themselves do not have access to data easily, to data in other hospitals or in other locations. So one of the ideas is to really accelerate understanding of brain diseases by gathering and organizing fragments of the data about diseases. I already showed you the Desisome, which is a beginning attempt, but we want really to drive the data together and drive massive collaboration between hospitals. So this is one of the missions of the Human Brain Project, which is a completely different mission than the Blue Brain Project, is to go into medicine and to try to make some kind of an organized, systematic putting together data on brain diseases from all hospitals in an accessible, systematic umbrella, the Human Brain Project. And then, of course, hopefully, when you put things together under one framework, the data from hospitals, from the physicians, into a systematic place, you may start to query, you may get answers much better than in the brain of a single physician or a single neuroscientist. It's now a collective brain put into a wise system, informatic system, about brain diseases. And I mentioned the future computing because you really want to learn from the brain itself, to be inspired by the brain, to build future computing technologies. So you want to, the brain is a physical proof that it's possible. And so how did the brain solve this problem of energy, of so many microchips interacting? How did the brain solve the plasticity, the learning, the fact that you learn while behaving? We want to develop this kind of computers inspired by the brain. So you can see that the brain can be our teacher for developing new technologies, supercomputers that do much, much better than today. And that's one mission that will be really important and probably will change society if we shall have this kind of adaptive, wise, and energetic chip computers. So I gave you a broad summary of the Blue Brain project seed and the Human Brain project, very different, large scale. Hopefully we shall know within 10 years, I'm sure it will be, a successful project whereby integration of many, many disciplines, computers, computer scientists, engineers, informatics, database, physiologists, anatomists, psychologists, put together in order to really, really dwell into a new direction of brain research. Next week, we will have a guest speaker, a well-known scientist, Professor Israel Nelken. He will talk about perception, action, cognition, and emotions in the brain. So thank you very much. See you next week.